Good day, ladies and gentlemen. This is a project by Harish Anantaraman, M. Abdullah, Vijay Ravi, K.S. Naveen Shankar, and myself, Shyam Ravi Shankar. In India, there have been 1,33,634 motorcycle accidents in the year 2014 alone. 32,524 people have been killed in these accidents in this very year. 1,27,452 people have been injured in these accidents. Now, these are not small numbers at all. And 40%, and this is an important one by the way, 40% of those killed and injured on Indian roads are motorcyclists. Nearly 76%, that's a huge number, ladies and gentlemen. 76% of people who sustain severe injuries to the head. A head injury means you don't know what you're doing, you've fainted, you may have passed out, fainted, anything can be happening, but you will be in no position to call for help. So there have been several cases where help has not been called for in time. Our solution is called the MCAS, or the Motorcycle Collision Alert System. We have three major parts of the system: bike, mobile phone, and cloud.
Now let's see the hardware part used for this solution. As soon as the accident happens, this force applied on the force sensor decreases the resistance of the force sensor. And then this Arduino, upon tracking the decrease in resistance of this force sensor, sends a signal to this GPS module. This GPS module, upon receiving signal from this Arduino, it triangulates the latitude and longitudinal coordinates. Upon receiving the data from this GPS module, this Arduino sends the signal to this GSM module, which has a SIM card slot in it. Upon receiving the data from this Arduino, this GSM module will then send the latitude and longitudinal position and details of the vehicles, etc. to the respective mobile numbers registered. Now let's run the code. Now I have activated the pressure sensor. The threshold value is displayed in the first line, and then the GSM module is initialized by giving different AT commands, and the GPS detects the latitude and longitude position, and then we are sending the SMS to this register number. See, the message has been sent.
This is the buzzer alarm that indicates that a message has been received with the latitude and longitude coordinates. The app has parsed this message, and here you can see the location on the map. As you can see, the location, which is my house, has been accurately triangulated.
Hello guys, I'm here to talk about the MCAS app which I've developed for the system. Now, as you can see from the menu screen of the app, it has several features for the user interface, and there's an about section for the app, a configure section, a map section, a report section, and a section which shows about all the action prone areas, and a data analytics section. Now, as you can see, the configure section prompts the user to enter his registration ID and also the device ID. Now, the device ID is basically nothing but the SIM card that's being used in the respective GSM module. That's a unique identification for that particular GSM module. And also, the registration number over here refers to the registration number of the vehicle that's being fitted with the GSM sensor. Now, when we look into the report section of the app, as you can see, it displays a list showing various cities. These are basically the reports that narrow down for each and every respective city.
So the data here is simulated data because we have obviously not been able to crash bikes in all these cities. Every time we do simulate a crash using our electronics part, which you see here, the data gets added here if we decide to report it. So there's real-time reporting, but this is all simulated data. So since this is a prototype.
Let's now go into one of the sections. Let's HNI. As you can see, some users have already reported instances where they felt that the roads were not motorable. The next feature of this app enables us to view all the accident-prone zones around the world. Now let's just look into it.
This data is not something a user enters by himself, but this data occurs when a bike crash occurs. This is an automatic and a real-time process, which is an integral part of the intelligence of our app.
Now we look into the data analytics part of the app. Now, as you can see, once we go into it, it gives us a list showing city-wise analytics, weekly analytics, state-wise analytics, and monthly analytics. Now, being a prototype, as of now we are done with the city-wise analytics. This gives a real-time analysis of all the crashes that have taken place and draws a percentage calculation of crashes that have happened in all the cities, and hence puts a pie chart form representation for all those data. Now, beautiful. As you can see, it has drawn a pie chart conclusion of the entire data that it's fed up on.
Hello guys, I am going to explain about the cloud architecture of our MCAS system. We have used Google Firebase Cloud Platform, which acts as an interface between raw data and analytics.
Now, here we will look into an overview of the cloud. There are several features in Firebase like analytics, authentication, database, storage, hosting, test lab, crash reporting. We will use the main feature as database. As it has been explained earlier in the app, the data will be passed to the cloud to this parent. The all location parent has been segregated to respective 5 cities.
Now we'll talk about the report side data which is being passed to the cloud.
As it has been explained earlier, the data which has been sent by the user to the report section will be passed to the cloud in the respective zones. You can see here.
The data will be segregated and analyzed by data analytics engine, which also provides feedback for developers.
Hi guys, I'm here to talk about merits and demerits of the MCAS system. Ultra scalable, thousands of bytes can be registered without changing a single line of code on the app. Robust, it has very low probability of failing. Time and cost efficient, there is no delay in sending the data that enables us immediate emergency services. Information reaches the family members, thus preventing commotion.
Now the limitations. Every system has its own limitations, and we thought we'd tell it to you before you figure it out yourself.
The app is not portable between different operating systems. If custom boards are used to build this, the cost will be much less.
Industry-grade materials must be used to package the entire system. Yeah, whether you like it or not. So don't worry, I'll be very sharp this time. So this is just to tell you all thank you. I hope you did enjoy your solution. If you have any feedback for us, please post in the comments below.